introduce myself. I'm Brian Heimbigner with ABB Incorporated. I'm the North American Business Development Manager, specifically for water, predominantly focused on integrated automation and power systems for ABB, supporting our customers in the water industry. What I'm going to be talking about is membrane systems and desalination. It's going to be, most of the desalination, of course, is focused on seawater historically throughout the world, but in the broader sense, we're also talking brackish water in the industrial sector. It's begun to be used in there for sometimes makeup water sources for prior to demineralization, prior to cooling tower usage. So the RO systems will have a lot of similarity between those different applications, and then they'll have some uniqueness to themselves. The main purpose of this presentation is to talk about what are the major challenges that people face with ROs, and that's the challenge of fouling, which reduces the productivity of the RO system in terms of throughput. It increases often their energy consumption, and in some cases it can even cause problems with the product quality. So we're going to be reviewing a bit on that. And then wanted to get into a technology that was developed by ABB called OPTIMAX with the express purpose of enhancing the membrane performance in an RO system, and also at the same time helping to try to reduce or conserve the energy, since that's a very, very important part of the RO operation. And we'll talk a little bit about the system architecture and a couple case studies, and then get into the benefits and summary in RO plants. But we will be talking today about, within an RO plant, the breakdown, or I shouldn't say the breakdown, but the different divisions of RO units, RO trains, and then finally the pressure vessels and the actual membranes that are inside the pressure vessels. And a little bit to be said about pretreatment, of course. Depending upon the source of the feed water to the RO system, will have a great effect on what the pretreatment requirements are relative to things like suspended solids, organic removal, colloidal solids, things of that nature. I'm not going to get into that whole lot. I just wanted to recognize that most RO systems will have some form of pretreatment, and it can vary across the whole range. Post-treatment, we're usually talking about if it's for a drinking water supply and it's going to be transmitted any great distance, like from an ocean inland many, many miles or kilometers. There's going to be some sort of storage devices right there at the desalination system, and then pumping stations, and there could be intermediate storage in between. Do need to have some adjustments on the pH usually to be able to make sure that it's not aggressive on the materials of construction of the piping system, and it may be necessary to also have some residual disinfection. And RO, you're all quite familiar with the fact then that it ranges over in the high pressure range as far as the comparison to other types of membrane systems that we're showing up here. And it also is over in the range where it has the smallest allowed transfer size as far as molecular size. Many of these other ones are based on actually taking out suspended solids. By the time we get to nano and reverse osmosis, we're talking about taking out molecular-sized contaminants, particularly being, in the case of desalination of seawater, it's predominantly sodium chloride. To get into the fouling, I realize this is something that would be second nature to you, but I just wanted to emphasize the fact that the fouling is created, for the most part, by the fact that we have a concentration, a localized concentration right here in a typical RO membrane. And what we're depicting, this is a RO membrane in kind of the flat plate type arrangement, even though most of them are spiral wound nowadays. But basically what we're identifying here is where the feed water comes in, it's under high pressure. We have the semi-permeable membrane that's going to allow the water to pass through, and the larger molecules of the dissolved salts and gases to remain behind. And we better not have any suspended solids at that point, or we'll be really plugging up the RO on a regular basis. But the water will pass through, and concentration of salts and other things will remain here on this surface. And that's where the fouling is going to occur, as we get a localized concentration in the system. And with the fouling, then we're going to have a couple different effects here. One is over time, our differential pressure between our feed pressure and our permeate or our product water pressure is going to have to increase in order to maintain the same amount of product production, or conversely, we're going to see a decline in the permeate or the product water production. And of course, both of those are negatives, things that we wanted to avoid because they overall cost us money in the operation of the RO system. One phenomena that we've noted, and this is not just ABB, but I mean the whole industry that uses it, is that fouling can actually occur in some stepwise formations, and it may due to the fact that all of a sudden a bigger glob of stuff shows up at that localized concentration site, and as you can see, it can actually then sometimes drop off because it might flush itself out naturally, or I'll get into a little bit on the cleaning of it where it would actually drop that down. Whereas the fouling thickness is kind of a more of a gradual upward lineal type approach. Now, as far as restoring the membrane's performance, that's been done for many, many, many years, and of course there's been a lot of input made on that from the manufacturers of the membranes themselves, and they're constantly trying to make improvements to make sure that they get the optimum performance. And RO has really come a long ways in the last 10, 20 years and has really replaced a lot of other types of technologies, and particularly thermal technologies and desalination. But the rule of thumbs you'll get from OEMs of membrane systems will be, they'll indicate how frequently the RO membrane should be cleaned by back flushing it, and then you can do that a number of times, and that's less aggressive than trying to do a chemical clean, and they'll give you rules of thumb for chemical clean. Now, a little more scientific approach is to take a look at the ASTM standard on it, and it begins to pull in a little bit more science into it relative to some of the conditions of the membrane and the water and that sort of thing. But again, on both of those, the drawback on each of them is that often we would end up cleaning actually earlier than we need to, which will help or cause degradation of the membrane over the life of the membrane, and it'll take something out of service when we really don't need to. When we do a rule of thumb, we'll do that. Whereas if we take a look at the approach that we're going to talk about here today, it actually takes a dynamic view. It's getting data all the time on the operation of the system. And of course, the operation of the system is not static either. There's going to be some changes relative to the potential changes relative to the concentration of the feed coming into the system, relative to the temperature, relative to some of the contaminants that are in there. So the system we're going to talk about today has a more dynamic review on it. It isn't instantaneous, but it's more on like an hourly basis or after an hour or two basis. As compared to these rules of thumbs, they're just basically, taking a look at how the production is doing over days, weeks, months, and eventually then saying, okay, our membrane manufacturer recommends we ought to do a backflush on it, we better do a backflush on it. I have already mentioned how to restore the membrane. One of the approaches is flushing, where we're basically taking and backflushing the membrane. I should have mentioned at the very beginning too, in any RO system it's standard practice to be able to always have one more train than is needed. If you want to have 5 trains to be able to do the amount of production that's necessary, you would actually install 6 so that we can always have one that we can, when we take one out of service, we've got the other ones to still give us full capacity. So with flushing, we are going to be taking the train out of service and we'd be back flushing it, and that cleans out a certain amount of the fouling. And I'll show you a chart in just a moment as to how well that can restore it. Chemical cleaning, our definition of that is that you're going to be basically running a cleaning solution through. It'll be what we call clean in place usually, where a cleaning solution is run through the membranes and helps dissolve some of the localized fouling. If it's some of the dissolved salts that have maybe crystallized out there, it'll dissolve some of the ones that are still soluble and then flush them out, and it gives even a better cleaning, a better restoration than flushing. Partial replacement, we're talking about there could be times when it's determined that one pressure vessel is out of a whole array of RO pressure vessels is the one that's really producing bad water all the time, and it's actually creating problems with the product quality. It's possible you have to take that whole train out to be able to get to it, but it's possible then to just replace all of the membrane cartridges in that one pressure vessel and be able to then restore the product quality significantly. And then total replacement, this is going to have to occur on any RO system eventually. I've asked a lot of the RO manufacturers that make the membranes, what sort of a life expectancy might we have on this? And some of them do give guarantees. The guarantees tend to be, on the conservative side because they don't want to be paying a lot of money out of pocket, and they're not operating the system, so they don't have control over it. So some of them will have guarantees of 2 to 3 years. Typical life expectancy on the membranes on an RO membrane, spiral wound, most of them will be talking and telling us it's between 3 and 6 years, and it has a lot to do with how they're operated, what's going through it, how frequently the cleaning is done and that sort of thing. The different levels that within an RO plant, we have RO units, and then units are made up of trains. Trains are made up of individual modules that have the membrane stacked inside of them, and those are pressure modules, pressure vessels. The OPTIMAX program basically has 2 components to it. One is a monitoring approach, and then it takes the data from that monitoring, runs it through some algorithms, and presents some optimization recommendations. I mean, it doesn't actually physically have control over your RO system and make these changes, but it puts itself on a dashboard, on a screen, for the operator of the system to be able to take a look and say, okay, this is what it's really telling me. Beyond the rule of thumb thing that I had to do a backwash every 3 months, this thing's telling me, gee, I could wait another month or 2 because the condition is not that bad. So that's what we will be talking about also today. Now, we got a lot of words up here, but there's a couple key points, I guess I'd say, relative to the performance monitoring, and I've tried to underline them there. One is that this software will be available to work on different membrane configurations. It's not just one individual manufacturer, and it's not just one specific type of membrane configurations, which I think is important because there's a very broad field of RO membranes. There's no additional sensors needed. We're basically taking data off of, assuming that the RO system is fairly well instrumented to begin with. So there's not a lot of, we're really not looking at a lot of hardware investment. And then the other items that I wanted to identify over here on the benefit side is that the ability to be able to identify the due date for the next membrane cleaning and backwash, I think are really some of the key features that come out of it relative to the membrane, because that should then help extend the life of the membrane, reduce the amount of operation and maintenance costs of the actual people in your facility. And then further, there's some information that comes out of the algorithms that helps to tune the model to try to optimize and get the membrane operating at its peak performance. And one thing I should mention, the question might be, well, would you just go sit in a closet someplace and do a whole bunch of calculations and come up with this information? And the answer to that is no. We've got some very, very highly skilled engineers that, of course, did the calculations and then took it to some pilot units initially and determined whether their calculations were valid, made some modifications to it, and then have had an opportunity to, on the first times, beta test it on some full-size operating customer units. And that's one thing great is on a unit that has multiple an RO system that has multiple units in it, is you can pick a couple of the trains and operate on those without affecting the whole system or without having to have the whole system out of operation. Now, this chart was, as I indicated, wanted to show you how naturally membranes are going to degrade over time as far as their performance. That's just a standard of life, I guess you might say. And if there was no cleaning or back flushing, this particular line here, there's a number of different performance indicators that you could look at on these, but let's just, for instance, say right now this is product water. quantity that's coming out. It could just as well be the flux going through the membrane. A lot of these things are interrelated. But let's say this total amount of product water. If we didn't do any cleaning or any backwashing, there would be a degradation, a pretty sharp drop-off in the performance of the membrane over a period of time. Now, if we add cleaning and backwashing, and first off we're going to do the backwashing, the flushing, we call it up here, because it's less intrusive, less aggressive, we're able to restore from this point back up to this point on each one of these subsequently some of the performance of the membrane. But as you can see, the performance doesn't go straight across anymore. It doesn't maintain, like it was new right out of the package. There will be some degradation, and that's just normal too. But look at the difference between the line up here and this line down here. And so it's real important to know that even cleaning and flushing on a regular basis are very, very important. Now, another KPI could be the energy consumption, and this line being represented by that. And as the membrane degrades some, the energy is going to go up a little bit. Then you flush it, and it performs better. It comes back down a little ways, and so forth, so on. But the overall trend is going to be up. And what we're trying to do with our program is reduce these slopes so that the overall downtrend is not quite as steep, and the overall uptrend on something like energy is not quite as steep. And we've been able to prove that OPTIMAX can do that. This is one of the typical of some of the dashboards. There's all sorts of different dashboards that can be presented for the customer depending upon what their specific requests are. In ROs and with this program, we can then come down and real quickly see that we've got one train here that's going to be requiring some cleaning, and this is approximately the due date that we ought to be looking at, plus or minus a day or two or something like that. But it's something that, by rule of thumb, it may have told us to clean 2 months before this time. We would have been really wasting some capacity at that point. And under other rules of thumb, we might have missed this cleaning period based on the actual performance of the RO system. And if you miss it significantly, it can get to the point where you can't restore it adequately at all, and then it has to be a membrane replacement, which then, of course, adds to the cost. The key thing here that I wanted to bring your attention to is by optimizing the operation, we're actually seeing maximization of product flow, which is really the whole purpose of the RO. We're trying to produce a product that can either go to your industrial facility or we can go to a drinking water supply or whatever. We want to minimize the SEC, which we've got the abbreviations down here, specific energy consumption, and we will feel that if we manage those two things, then it should maximize the profit. If you're an industrial client, then it's reducing your costs, which in turn then means that your profit's been maximized. If you happen to be a municipality, it would reduce your costs, which means that overall you're serving your community better, and you're not going to have to, raise the rates as much in the future. As we said earlier, a standard RO train is going to have a fair amount of instrumentation on it. It's going to have the pressure, the temperatures, the flow rates, and that sort of thing. And also concentration like conductivity meters on some of the key streams that we want to know what that's going to be. With the OPTIMAX system then, effectively what we're doing is we're gathering a lot of that data essentially electronically, and we're taking a combination of this, running it through the program and the algorithms based on that membrane and based on our past experience on other projects. And that's where we come up with the predictiveness of how well a system is operating right now, whether any of the set points ought to be changed on the pressure or on the flow rate, things that we can adjust. We can't adjust the concentration coming in, that's given. But on the things that we can adjust, the program will be able to advise on that. And then also the predictive nature of the future for when things need to be cleaned, when things might have to be backflushed, when things might have to be replaced. Now, this particular one is a little bit different configuration in that we've got a Pelton wheel on it here, which is a turbine that the reject water will flow through. Now, the reject water comes out at an elevated pressure still. It's not nearly as high as the feed water going in. but it's got energy in it, and so there are ways to be able to run it through a turbine, and this is a very, very simple approach to do it, and then that adds some energy that can go into effectively a motor that will supplement the high pressure feed, because this is the single biggest energy consumer on the RO system. And again, with taking information that's already out there from the instrumentation that's in the system, we can pull all these different things together, the recovery rates, feed pressure and flow, and bring it up here and feed it into our performance monitor first, which then in turn it can feed information over the optimizer, which can help tell the system or the operator of the system if any of the set points ought to be changed in any way. Additionally, then that performance monitor is doing the evaluation on the cleaning and the replacement schedule. Now this is a little bit more sophisticated. Many of you are probably familiar with energy recovery devices. They've come on the scene here probably, I'd say real successfully in the last 10 to 12 years, and they're really important for larger RO systems. And effectively what they're doing is they're a sophisticated approach to taking the energy out of the reject stream and basically energizing a portion of the incoming stream. You can see the feed supply comes in and it splits between going through this pump this way, and it's still a low pressure, let's say it's seawater, and then the rest of the seawater go up here and go through the high pressure. Effectively what this is doing then is, of course, cutting down on the total energy consumption of the high pressure. And again, that's very important because relative to any of these other pumps here, the high pressure is undoubtedly the largest energy source, energy consumption on this chart. So this one, we're not involved with energy devices. There's a number of companies that do design and supply these on a regular basis, and they're very, very good for this particular membrane industry, for the RO systems. But again, we can work with that to be able to take some key information out of here, like feed flow, the pressures, and run them up into our performance monitor. And you're probably wondering, well, what are the calculations that go from taking all this data and run through the performance monitor? Well, this is kind of like similar to the Coke formula. If they told me they'd have to shoot me tomorrow, so I don't even know how it works. It's some of our more esteemed colleagues over in Germany and other parts of Europe that have come up with this. But again, the whole idea being that we can be able to identify the optimized set points for the entire system and also the cleaning and maintaining. As far as the system architecture, one of the things I wanted to mention is that I start with this one here because it says DCS system by ABB or third party. There could be an existing RO system at a plant, and let's say for a minute this one isn't even there. It's just an existing RO system somebody wants to upgrade. Our technology is compatible with talking with other people's DCS. It doesn't have to go in and replace a DCS with an ABB DCS in order for this to work. Effectively, the data would be coming out of their control system, and we can pull that up, run it through our program and our algorithms, and then give the output to the customer in a format that's very, very easy to use and very easy to act upon. Now, if somebody was expanding their RO system, of course, we'd like to be able to talk to them about then the opportunity to supply them an ABB DCS and be able to then still feed. It doesn't matter, it wouldn't matter if we had like 3 or 4 other third parties here. We can integrate all of them into a single system, and there's basic parameters that we're looking for, and then from those parameters we make the calculations and come up with the best recommendations. The additional features that you'll find in this OPTIMAX system then is information management. It'll collect all of the data. This is one thing that we find kind of frustrating sometimes. You go to an RO site, somebody's got a rather large plant, multi-million-dollar investment, and you ask them for, what is different about your RO right now today than it was over the last month, the last 6 months, and a lot of people don't have any data whatsoever. They at one point, they saw it all out there on their equipment. They even maybe had it come into a central HMI and saw it as data printout, but there wasn't any sort of collection. There wasn't any sort of basically what I would say analysis of that and reduction of that data down to meaningful information. With this system here, that can all be accomplished. Of course, we can't go back and recapture people's stuff if they lost it, but we can go forward with it. And that's important because if you're going to invest in an RO system and have millions of dollars tied up in it, it's not something that's going to be a throwaway in 2 or 3 years. The membranes maybe have to be replaced, like I said, in 5 to 7 years. But it's something, particularly if it's for production of industrial water coming into your plant or drinking water, something like that. These systems are going to have a fairly long life. You know, there's no reason why they can't be there for 20 years. Now, technology will probably obsolete them before they actually wear out. As far as reports, one of the things that we really pride ourselves on is not only designing something that makes sense for our what I would say our colleague engineers at our customer's company, but we want something that is designed with the end operator in use. I mean, it's kind of like a car. You get in a car and you go, why in the heck did they put that dial over there? That's impossible to see in the dark. And you're thinking, well, some engineer had the responsibility for that quarter of the dashboard to take care of it. But did they ever go out and beta test a whole bunch of customers and have them drive this car around in the dark? That's the thing that we want to avoid, and we want to be able to get it to the point where the reports are useful for the operators, they can take actions on it, and then when engineering needs to get involved, it's also got the information that they can have. It's all accessible. It's, as we say, thin client, so basically they're not having to buy a whole bunch of hardware and servers and information like that. It's available to them like that. Also, from a standpoint of alarms and event management, we're fully compliable with whatever the locale is. Being a global company, we of course have to adapt to many, many different countries and what their requirements are, and to the specific customer too. If we're doing something in the oil and gas industry, of course, some of their requirements are significantly different than what we would find in a power plant or in a water municipality. Case studies, I'm just going to go through some of these briefly here, and we can discuss them later afterwards if you have more questions. But this is one that I indicated that we were able to take 2 trains out of a total of a 10-train unit and be able to do an evaluation on it. This particular one did not have any energy recovery device on it, which kind of simplifies the whole activity a little bit more. And it was a fair size train that we were working with there. And this is the sort of data then that you get out of the evaluation. And the objective here was to monitor the membrane performance, do the calculations on the optimal set points, and then with that, calculate what the feed pressure and the product flow ought to be able to optimize it. And these charts are, I'm sorry, they're a little bit on the smaller side, but effectively what you can see here is that on things that were starting to degrade after we got the system running, the OPTIMAX system running, we were able to basically maintain it where it was at that level and pretty much have it not get any worse at all. And this is a little bit bigger chart. This is one that I think you can see the impact here. On this side of the line here, things were before the OPTIMAX system kicked in, and we had these different KPIs, and these two here that were declining at a fairly sharp rate. You can see after the OPTIMAX, we were able to restore it back up to a higher level. It still had a decline, but eventually we got it to a point where it was essentially flat-lined out on the fouling, and that's real important so that no further degradation was being made on that. And similarly, on the product water, we're actually able to raise that up a little bit as far as the quantity and then keep it at a steady state. On this particular case study, we had gaps that were fairly wide between what was the optimal condition and the actual condition. And in both these cases, this being product flow and this being feed pressure. And after OPTIMAX was put in, it takes a little while for the effect to take place. It did bring up in both cases and minimize those differentials that we would like to see as the positive effect. And on this one, I just wanted to cover that there's really 4 major components of this OPTIMAX. There's a simulation or a simulator, there's scheduler, membrane management, and load distribution. And this is important in the sense that with a simulator, we can actually do what-ifs. We can take the system after we've loaded it fully in, know all of its normal characteristics, know what its current characteristics are, and be able to simulate by changing some of the parameters, you know, the pressure, the concentration, and things of that nature in case the customer thinks that they're going to be seeing something like that in the future, and be able to predict then what the performance of the system is going to be. The membrane management, I think we've discussed that enough already as far as relative to lengthening the life of the membrane by proper cleanings and proper flushings and how we set the set points on many of the parameters. As far as the scheduler, this is actually the program then that would identify when those cleanings and when the membrane backflushes should be taking place. As far as a load distributor, I kind of attributed a little bit to this earlier where I said, you know, let's take, for instance, one of these trains has had some sort of a membrane failure. It could be mechanically within the membrane. It could be that something got through that train and it just really clogged it up and it's not restorable. We'll be able to detect that particular membrane or that train as being the problematic one, and again, being that we have n number of trains, in other words, we need to have 4 of them in service and we've got 5 of them total. We're able to isolate that that's where we need to fix the problem. We could take it out of service and replace the offending membrane, or we may find out once we get in there that, you know, all the membranes have got problems with it, and essentially be able to get that one back up to a much, much higher performance. But before we ever did that, we would be able to do load leveling on the whole system, be able to continue to get the product amount that we wanted at the product concentration and with reasonable amount of energy consumption. Dashboards, this is what I wanted to show was, as far as the dashboards that come up for the operators, these are some of the sorts of things that they would see. It would have things up there for the overall RO, what we call the decision support system is what this OPTIMAX is really, and then another category called membrane management system. And they can essentially be able to pick on any one of these different subject matters here and then pull up a custom screen for that. It's you know, very logical what they're going to be looking at, and again, the use of these different colors, yellow, red, to be able to, yellow, red, green, to be able to highlight when we've got serious problems that we need to be able to take care of, or when the system's operating perfectly fine, it's time not to touch it. So, in summary on this particular technology, I wanted to say that its main focus is to be able to overlay on existing RO systems that are already out there with minimum amount of investment in terms of capital. It's mostly software. We're taking taking information from existing instrumentation that's already on the RO system. Now, if not everything was there, if it wasn't all instrumented, then of course we're prepared to be able to work with the customer to instrument it properly. But take the information and analyze it in algorithms that are based on true operating situations of many, many, many other systems, and then create a recommendation in a couple different levels of critical levels, green, yellow, red, as to whether cleaning ought to be taking place on the membrane, backflushing ought to be considered, membrane replacement, and then also the other part of it is to be able to identify, besides the maintenance schedule and the predictive maintenance, is to identify the set points that are key to the operation of the RO system to be able to optimize it in terms of energy consumption being as low as possible and actual product production being as high as possible in terms of both product water quantity and the product quality. And as this chart shows, it can be implemented on both reverse osmosis and nanofiltration. Those tend to be the two membranes that are up on the higher end pressure and where things are a little bit more expensive than, say, some of the lower end ones like UF and microfiltration. And we've gone through the benefits. Basically, isn't it all true that all of us, when it comes down to whether it's industrial, whether it's for our companies, or whether it's for our families, it's how do we make life better and how do we keep money in our pocket rather than spending it. And that's really what this system and this technology comes down to, is it makes life simpler for the operators of the RO system. It ensures a higher productivity for their system, reliability, and it reduces their costs by not getting into situations where they have premature wear or premature failure, and are able to make whatever product that their objectives are. Thank you.